Okay, exercise 8 now on stored procedures. So in this one, we're going to use the Sport Motors database, which is actually a very interesting database. It presents a number of situations where we have to make decisions based on the fact that there are multiple relationships between certain entities, right? Actually, let me bring up the database diagram here for a sec. This is one that you have a copy of already. Pardon me. Okay, look for example at even the employee table, right? So the employee table, of course, employees place many orders. That's a simple one-to-many. This one here, no big deal. How about the fact that there are two different one-to-many relationships represented here with the sport department table? Okay, what's going on there? Well, basically what we're doing is, look for the primary and foreign keys. And if we're going to follow naming conventions here, department ID, okay, is a parent in a parent-child relationship to employee, a one-to-many. A department has many employees and employees in one department. That's the idea here, and that's why we see department ID, the foreign key in the employee table, okay, relating back to the primary key, department ID, in the department table. That's this line right here. Oh, sorry. This one. Okay. All right. Now, what's this line representing then? You might say, okay, well, the primary key of the employee ID, okay, the employee could possibly be the manager of multiple departments. Okay. Department manager ID is the foreign key relating to employee ID from the employee table. That's another way that there's a relationship between the two, right? So department manager, okay, is of course still an employee, right? What's this one in the upper left corner here? This circle, so to speak. Well, what that represents is that there is the employee manager ID here. Sorry, I just had to cough. All right, so basically that is an employee ID where that's the employee ID of the employee's manager, right? So that's another way that one employee can relate to another employee, that they are their manager. Okay, so there's lots of examples of things like that. One we're going to actually work with shortly, another one, is the way that inventory relates to the category and subcategory, right? So we see here that we've got a few different ways we can go directly, that a category is in a one-to-many with inventory, because all inventory items are in a category, but yet the same thing is true with subcategory, right? And yet subcategory and category are related to each other. Oh my goodness, what a complicated mess, right? Well, we'll talk more about that when we get to the second question, but let's start off with employee and department as per the instructions themselves, right? So here we are. Number one, we want to get department ID, department name, and manager. Now the full name, the first and the last name, okay, of the actual manager themselves. So the names, as we've seen here, there's no names in the department table. The names are in the employee table, right? So we are going to need both the department table and the employee table in order to get the information that we need. So let's go into SQL Server now, okay? So here's the actual question, right? Get all this information ordered by, et cetera, right? So it's up to you if you want to just write it from scratch, but I'm going to continue to show you some of the flexibility you have with the query design editor, right? I like it in particular when it comes to working with the actual, sorry. Oh, yeah, I'm still in the master database. That's why I didn't execute my use command here to switch, so I'm using Sport Motors. Okay, there we go. So let me just get a little bit more screen real estate going here. Once more, back into the editor. Now I see all the tables. Okay, so we know that we need the department table, but we also need the employee table. That's where the names are stored. So I can just close that for now. And then look at these relationships. As I said, okay, what we have right now are these two relationships to decide on. Okay, so which one is it we want to use? Well, we did kind of talk about, okay, this is the foreign key. This indicates what department the employee is in, but this is the ID of the manager, the particular employee ID of the employee who is the manager of the department. So that's the one we want. So, we rarely want to build a query based on multiple relationships, or there's just going to be confusion. So we will remove the one that we aren't basing our query on, right? The query is based on the fact that a department optionally has a department manager who's just an employee, so we can relate that to the employee and get the information we require there. All right? So what is we need? Well, let me just move this down. You can see the question right there. We need the department ID. We'll check that off. Add that to the projection, the department name. Okay? And then, of course, we want the first and last name. We'll worry about putting it together into one a little later on. So we want the first name and the last name. And notice they're added to the projection down below in the order that I click them or check them off, okay, in the query design tool. Now, one other thing, besides concatenating the name, ordered by department name. Well, I didn't point it out earlier, but in this middle section of our query designer, right, you see that we have additional options. We have sorting, okay? So department name, I'm going to apply a sort here, ascending, okay? So it'll be alphabetically ordered, A to Z, right, by the department name. So that's the first order. So, if I was going to sort by additional things, then I could change the sort order numbers here, but I only have the one, so that's good. So that's basically it. So we can see the query as it's done so far down below. So I'll just click OK to put the query into the actual script, right? And there it is. That's what we're seeing, department ID and so on and so forth, first name, last name. All right, and it is ordered. So we're on the right path. Now, one thing we have to be careful of, and it's always a good idea, let me just come over here to my databases, we'll come down here to sport motors, tables, etc., right? Let's just have a quick look here in the two tables. There's a lot of information we can get just right here in the Object Explorer. And what I kind of want to point out, always be thinking about nulls, okay? What things allow null and what don't, right? So we can just quickly glance here and see the department manager ID, even though it is a foreign key, look at that, it allows null. In other words, there might not be an employee assigned as the manager for a given department at every point in time. It allows null. So there might be someone, the manager's quit and left and they haven't appointed a new manager yet, right? So that is a bit of a warning to us. Whenever you have a relationship, a join, you have to look and see, okay, is there something I should be concerned about? And we definitely want to include all departments, even if, right, even if there is no manager assigned at the moment. All right, so let me just go back into the query design tool again. We could have just done it right in the code. That would have been fine. But we can change that here just by right-clicking on the join and saying, hey, all rows from department. And as I make that change here, you see the icon change as well, and it's changed to a left outer join, okay, from department to employee. And that's exactly what we want. Now, is the result of executing the query any different? No, exact same 5 rows are coming out, but that's okay. Just because we got the same answer doesn't mean that this isn't a better answer. It is, because that's just based on the data we have in our tables right now. Going forward, we could at some point have a department that there is no manager assigned, and this way we're guaranteeing that we do actually have all the data for every department. Okay, so the last thing I really need to do to answer the question is maybe I'll press enter here, get it all on the screen. Okay, put this into our concatenated form for the first name and last name. So I can just use the built-in concat function, right? And you've used this before, so you just have a comma-separated list of all the fields that you want concatenated together. So I'm going to have the first name, then I'll just put a space, comma, or quote, comma, quote, space, quote, comma, there we go, right? And that would work, but what's the problem I'm going to have right now? It's going to just show no column name here, right? Well, that's not good. So we were suggested it should be, and as shown in the screenshot, we need an alias here as manager. Okay. Now I think we have it, right? There we go. And now we should be getting exactly the output that was requested, okay? But, in terms of evaluating it, just because you get the right output, I would be checking to make sure you do have the left outer join. If you want to get full marks, for example, on a test with a question like this, you have to take those factors into consideration. Okay, well, that's just getting this query together. Question 2 is we're going to write a stored procedure, essentially based on our query, right? Take the department name as input and returns the full name of the manager as output. Now, I'll be honest with you again. This is the kind of thing that I probably would not do normally as a stored procedure. This is obviously a function, right? Where we can just have an inline function where we pass the parameter is the department name, and then it returns, and we can use it right in line wherever we want, the full name of the manager as output. But hey, we are learning stored procedure, so we're going to do this as a stored procedure this particular time. Okay, so I'm going to create the procedure. I could use create or alter, but I'll just use create procedure. I'm going to call it USP for user stored procedure department manager. And then I need 2 parameters. Okay, I need the department name as input, right? So I'll have that. I can use my own short form here for department name, varchar 50, and then I need a output parameter. So I'm going to use at manager name, just short form for that a little bit, right? And there we go. Then as, oh, okay, and then we'll get the code in place. But before we go on, very important, I want to talk about this, right? The manager name is basically going to be this, what we've put together up here, right? That's exactly the output we're looking for. Just a warning, just want to make sure you're aware, again, for full marks on something like a test, we're going to be looking at what values you choose, okay, for the size of your variables. So department name, we're choosing a varchar 50. Well, gosh, where does that come from? Well, again, look over here in the Object Explorer, and there's a quick way to look and see department name. The column itself is defined within the sport department table as a varchar 50. So that is why we would choose that as the data type for the input parameter itself. Okay? Now, the manager name, well, that's a result of an expression being put together. So let's come down and look at the employee table where the data we're putting together for this output parameter comes from. The first name and the last name are both what? They're both varchar 30. 30 plus 30, okay, because we're concatenating them together. So allowing for the maximum size of data that is allowed in the actual table column, 30 plus 30 would be 60, okay? Why did we go with 61? Well, remember, okay, we're going to concatenate a space here between the first name and the last name. So that's one extra character. So that's why we're going to make our output parameter a varchar 61. Okay, so I might as well just get the rest because it's essentially the same code that we had up above, right? Just rearranged slightly because all we really need to do is assign our output parameters value. I don't need to return any other field, department ID, and so on. We're just using select to assign the value from our expression, the same expression we had, into the output parameter MGR name, right? Notice we don't need an alias here because we're putting it into this parameter. Okay. Now the from clause is the same. We have our left join and so on and so forth. And away we go, where department name equals department name. Oh, you notice here I'm using table aliases. I kind of skipped that up here. Unless you're told to use table aliases, I won't actually deduct marks. But you know, it always makes the query more succinct and easier to read, right? And I'll show you once more that trick. Let's go back to number 1 for a second. So the support department, okay, I might call it as I'm doing here, D. I could say as D, but that's understood. Okay, and the employee E, right? Now, right now it's underlining. I could do a search and replace. I could manually go through and fix them all. But another easy way is just to go into the query editor and click OK. And there we are. Now, the only thing is, because the concatenate function is here, right, it just changed the code slightly. It's not a big deal. You can leave it, or you can just take this out. It's just how the query designer, it's very precise, right? So it's saying, hey, we have an inline function here that we're using, concat. So it uses that particular syntax for it. Does it work without it? It certainly does, right? So just to prove that, let me run this again. And you notice that the output is not changed, but we have switched the actual SQL as it's written to use the table aliases as pretty much as I've shown down here in the stored procedure. Whew. All right, let's go on. Let's actually create the stored procedure now. I'll execute that. So we've created the stored procedure, completed successfully. So a little test script to make sure it works. Okay. Quick example of putting it into operation. I'm going to call to execute my department manager stored procedure. I'll pass in parts, okay, and then I'll have a variable here to receive the output parameter. Let me emphasize, okay, the name of our variable that we declare does not need to match the name of the parameter used internally inside the stored procedure. In fact, just when I call the procedure, I would have no way of knowing without doing further investigation what the name of the parameter actually is, because I'm just passing by position, right? I could easily find out, but just pointing out the fact that the name of the variable does not need to match the name of the parameter. Don't even need to know the name of the parameter necessarily. Okay, but very important, the data type, okay, for my variable that I'm creating to receive the output parameter's value should match, right? So again, we're going to be looking for varchar 61. Let's do our test, and bada bing, bada boom. There we go. Pardon me. My allergies are a bit bad today. I apologize for that coughing. Okay, there we go. All right, so there's the name of the manager of the parts department, right? What if, now notice that our query is looking for direct equality, right? Our where clause is that the department name exactly matches the input parameter, the value we pass in. If I change this to just part, what happens? What do you think will happen? Well, there is no department with that name, so nothing will be assigned to our output variable. Hence, we should get null, right? And that's exactly what we do get. It doesn't cause an error. It just says, hey, no, there was no value to provide. All right.